Hello and welcome back to Ganesh Institute channel. So in today's video, we are going to discuss about the continuity and differentiability of a function. So though we have already talked about continuity in our previous videos, but still to make you understand more about differentiability, continuity is the basis. So let's get started with an example, okay? Here you can see that function is given to you cos x modulus of cos x plus modulus of sin x. We need to prove or find out that fx is differentiable or not. First of all, please remind this, please make sure you remember this, that for continuity, any function to be continuous, that means the limit, the left hand limit, the right hand limit, and the value for fx at particular point must be equal. Then only you can say that that a particular function is continuous. Similarly, for differentiability, what you need to do is your left hand derivative must be equal to right hand derivative, and this will prove that the function is differentiable. Okay, now how do you calculate derivative? So first of all, let's start with the limit. Okay, so for continuity, if you want to find out left hand limit, what it will be? Limit x tends to, what's the point? Pi by 2. So left is something which is less than that value. So pi by 2 minus of fx. What is fx? So if you substitute the value of fx, which is cos x plus sin x, right? Limit x tends to pi by 2 minus. Now you need to consider a small point h tends to 0. So that is something you will take as pi by 2 minus h, and that h is very small, h tends to 0. So now substitute the value cos, in place of x put pi by 2 minus h plus sine pi by 2 minus h and the modulus of that. Correct. So cos 90 minus theta is what? Sine theta. And then sine 90 minus theta is cos theta. And the modulus will be positive. You know, if you substitute directly, because it is not making 0 by 0 form, so you can put this value directly, h as 0. So sine 0 is 0 and cos 0 is 1. So your left hand limit is what? 1. Now for right hand limit, similarly you will put limit x tends to pi by 2 plus, correct? And then fx, which is what? Cos x plus sin x, and that too in modulus form, right? So now you have to put again similar way, h tends to 0, and then because it is pi by 2 plus, so you will put cos pi by 2 plus h plus sine pi by 2 plus h, and modulus of course, right? So when you first of all cos 90 plus theta, I would like to tell you about the Cartesian plane. See, this is your 0 degree, then you can see this is 90. So this is 90, this is 180. If you add again 19 to 90, then this is 270, that means 3 pi by 2, and this is 360, that means 2 pi. Now you have to find out pi by 2 plus h. So pi by 2 plus h is in second quadrant. You can remember add coffee to sugar or after school to college. This is the remember trick, mnemonic. So you can see after school to college, sorry, add sugar to coffee, not coffee to sugar. So after school to college, so here sine and its reciprocal, which is cosec, are positive. So cos 90 plus theta is cos theta, but because it is going in that, it is pi by 2 plus h. So that means second quadrant, where you have your sine and cosec positive. So you will have minus cos h. But minus cos h, after coming out of this modulus, it will become plus cos h. And here sine 90 plus theta, this is sine theta, but because it is second quadrant, so sine h, right? limit h tends to 0. If you put h as 0, so cos 0 is 1, sin 0 is 0. So you have both of the limits equal. Now if you have to find out, see, you have found out left hand limit, right hand limit, now the function. So value of function will be, if you directly put or substitute the value of x as pi by 2, so cos 90 is 0, and then sin 90 is 1, so 0 plus 1, that is 1. So because left hand limit is equals to right hand limit is equals to fx, so your function is continuous. It is quite visible. Now, but the question has asked us about the differentiability, so how you will do that? In order to find out your derivative, what you have got is limit x tends to c, fx minus fc upon x minus c. So this is your formula to find out the derivative. Now what is c here? This point, x is equals to pi by 2. So if it is left hand limit, you will put limit x tends to pi by 2 minus fx, which is cos x plus sin x in modulus form, minus fc. Fc is what? F pi by 2, right? X is pi by 2. So function, if you put f at pi by 2, what you will get? F at pi by 2 we have already found here, right? Here the value is 0 plus 1, which is 1, right? So you can directly put 1, divide by x, which is, you don't know it yet, but c is pi by 2, right? So this is your left hand limit. Now let me erase some of the part, just bear with me. So now if you try to solve it using the convention which I just tell you or just told you, just bear with me. So now if you see, if you substitute similar way just like you did it in continuity, in differentiability also, after having a limit you have to put value of h tends to 0 and keep that limit there. So see, if you put limit h tends to 0, cos, here what you have got is pi by 2 minus h, correct? And then plus sine pi by 2 minus h minus 1 divided by pi by 2 minus h minus pi by 2, right? So if you do so using your limit concept, you will find that if you put, see, cos 90 minus theta is what? Sine theta. It will become sine, and sine theta, theta is what? H is 0, sine 0 is 0. Here sine 90 minus theta is cos theta, that means cos 0, that is 1. 1 minus 1 is 0. And in denominator also you have only h, because this will be cancelled out, right? What you have got? 0 by 0 form, which will not work, right? You have to form something. So um, if you have watched my that video which is showing continuity limits, so you will see that in this case we will do differentiation of numerator and denominator. So if you do here, see, if you do the differentiation, cos x is what? Cos x is minus sin x, but because outside it is modulus, so it will become plus sine. Then for sin x you have cos x, a differentiation of sine is cos, so mark cos x, and then differentiation of 1 is what? 0, then we are not taking it. In denominator, differentiation of x is 1, so, and this will be 0. So now this is your question. So you will find, or what you can do, you have got up till here, right? This form, you can differentiate it further. So cos 90 minus theta is what? Sine theta. This is your sine h. This is your sine 90 minus theta is what? Cos h minus 1. by minus h. This is your value for left hand limit, right? So if you will put, now if you differentiate it, so value of sine will be, differentiation of sine is cos x, so you can say cos h, and differentiation of cos is minus sine, but because these are in modulus form, so you'll have plus sine h, right? And in denominator what you have got, minus h. So differentiation of h with respect to 1 is minus 1, here minus h. So if you substitute now, this is your form, sin h plus cos h minus 1. Now if you put h tends to 0 here, what you have got, sin 0 is 0, cos 0 is 1. 1 upon minus 1 is what? Minus 1. So your left hand derivative is what? Minus 1. Now if you talk about right hand derivative, so what you will do, just bear with me, I am erasing this. So for right hand derivative, what you will take, x tends to pi by 2 plus, right? So pi by 2 plus will make it, similarly, why it is not working, just bear with me. Okay, I've got enough space, right? So let's take another pen. So for right hand limit, what you have got is limit, so here is your right hand limit, right hand derivative. So it will be, instead of pi by 2 minus, it will be pi by 2 plus, correct, for right hand derivative. Then everything will be as similar. It's just that when you will put h tends to 0 here, right? So it will be pi by 2 plus h, because the limit is pi by 2 plus for right hand, then pi by 2 plus h. So what you have got is cos 90 plus theta is minus cos theta, but because it is in determinate form, I mean modulus form, it will become plus cos theta, right? So what you have got, I am explaining it here. So cos 90 plus theta is minus cos theta, but because it is in modulus form, it will be cos theta. Then here sin 90 plus theta is, this will be sin theta, and in second quadrant sine is positive, right? Then differentiation of minus 1 will be 0. So this is your, and in denominator differentiation of h is 1. Now limit h tends to 0. If you will substitute h as 0, what you will get, h cos 0 is 1, sin 0 is 0 by 1. That means your right hand derivative is what? 1. And because right hand derivative is not equal to left hand derivative, hence this function is not differentiable. And if it is not differentiable, then we will not have to find out any derivative, right? So I hope you have a clarity regarding this topic, and if not, then don't worry. You can comment in the comment box, and I'll make another video to solve that query. So if you have understood this topic, then please don't forget to like, share, and subscribe my channel. Till my next video, take care of yourself. Bye bye.